We are going to start with vectors. Any idea what is vector? What is vectors? You don't know what vector is?
Any quantity which has magnitude as well as direction.
Any quantity that has magnitude and direction. Okay, see, physical quantities can be classified into two categories. Okay, one is scalar and another is vector. Okay, there is third type also. We will talk about it later. For now, scalar and vector. So what are scalar quantities? These are those quantities which have magnitude but they don't have any sense of direction. Okay? And what are vector quantities? They have magnitude as well as direction. So vectors have magnitude as well as direction. Okay? Whereas scalar quantities have magnitude only. Okay? So you can have many examples of it. For example, scalar, distance, speed, yes, work, time. Many examples can be given. Vector quantities, velocity, displacement, acceleration, okay, force, etc. So there are many examples. Okay. Yeah, you can I note it down later. Just okay. So all these are examples of scalar and vector quantities. I think you all know this. Nothing new here. We will talk about it later. Okay. Or should I talk about it now? Okay, let me tell you. So anything that has got direction and magnitude both, it is said to be vector. Okay. But this is not the actual definition of vector quantities. Okay. For example, let's take an example of electric current. So, suppose this is current I, okay, and it gets divided into two branches, yes or no, I1 and I2, right? Or wait a minute, let me make it the other way around. Yeah, now I1 and I2, that was also correct, but this is easy to understand. The angle between them, let's say it is 60 degree, and it combines to form I. Yes or no? Now the thing is, the question is whether current is scalar or vector. Scalar or vector. So the thing that we have read, that it should have magnitude as well as direction to be a vector quantity. So current has magnitude. Yes, Shireen, yes or no? Current has magnitude or not? Okay, very good, Shireen. Current has magnitude. Array, speak up. Yes, okay. And direction? Yeah, current has direction or not? No direction. What is this? Current always follows a direction. Always has direction, yes or no? Okay. So, current has direction also. So, that means current is a vector quantity. Why? Okay. So, current is not a vector because Shireen and every one of you are saying that it does not follow. It does not follow law of vector addition.
Sir, am I audible now?
Yeah, you are audible now. Okay, it does not follow law of vector addition. Why? Because see, I will be a scalar sum of I1 and I2. Yes or no? Ram, we won't write that I will equal to under the root of I1 square plus I2 square plus 2 cos I1 I2 2I1 I2 cos 60. No, we won't write it like this. That is law of vector addition. We won't write it like this. Yes, we will simply add them. So one more important condition for a quantity to be vector is that it must follow vector law of addition. Okay. And current does not follow vector laws of addition. Hence, it is not a vector quantity. Right. So if current is not a vector quantity, then what quantity it is? So what is current then? Yes, Shireen, Gayatri, Anjana, Bhavika, everyone. What is current then?
Sir, current
Scalar,
is yes.
but scalar quantities don't have direction. Current
But
has
here we are
direction.
talking.
Yes, dear, what?
Here we are talking about the backflow of electrons.
Backflow? No, no, no.
No,
I'm
reverse
talking about
direction.
what quantity is current. How am I talking about backflow? I'm not getting your question. Explain what you are asking, Shireen. I'm not able to understand.
No, I was saying that it has direction. So why can't we say that it's vector?
My dear, we cannot say it is vector. I just explained it. Okay, you had
Because of that
read.
rule.
It does
But
not
what
follow
about
vector
direction,
law of
sir?
addition, dear. It does not follow vector law of addition. See, you are adding up the currents here. I is equal to I1 plus I2, right? You are adding it up. You are not doing vector addition. See, this is the formula to find the magnitude of vector. You don't do this thing. You simply add it up. Right or wrong, Shireen?
Yes, sir.
So since this quantity does not follow vector law of addition, it is not a vector. Vector quantities, here you can write in vector quantities, the most important thing is that they must follow vector law of addition. Okay? Yes or no? Clear, Shireen?
Yes, sir. But I'm still
यही तो
stuck that
प्रश्न है.
because
So
of the
what is
direction
current?
and
Is it a
direction.
scalar? Answer is no. It does not follow vector law of addition. Sorry, it has got direction. It is not scalar because it has got direction. It is not vector because it does not follow vector law of addition. Then what is current? So there is a third type of quantity that you won't study even in your graduation. Even if you go for BSc or BTech, no, you can't go for BTech. Then too, you won't study about this quantity. This quantity you study in your majors when you do post graduation. Tensor quantities. Current is this is R, not V. R. Current is a tensor quantity. Okay. Tensor. So what is current? It is a tensor quantity. What are tensor quantities? These are those quantities which have direction but do not follow vector laws of addition. Okay. So current is a tensor quantity. So if in your examination they ask you what is current and you have got option of tensor, so you will tick mark tensor. Okay. And if tensor is not there, then tick mark scalar. अब क्यों उसमें कुछ तो लिखेंगे ना, स्केलर वेक्टर कुछ तो ऑप्शंस देंगे. In none of these, mark none of these if they haven't provided you with this with tensor. Okay. So can you give me few other examples of tensor quantities? Has got direction, it is a vector quantity. My dear students, it has got direction, magnetic field, and it follows vector law of addition also. Pressure, you have seen it so many times. Pressure. In a beaker, pressure is equal to H rho G. H is the height. So as you move above the beaker, pressure decreases. Yes or no? So that means pressure is changing with direction. It is dependent on direction. But you simply add the pressure. Atmospheric pressure is added. You don't do vector addition, right? So it is a tensor quantity. Surface tension also, yeah, there can be many examples. Okay. Write it down, write it down. Understood everyone? Anjana, Bhavika, Gayatri, Shireen.
Yes, sir. Yes, sir.
So vector quantities are those quantities which have magnitude, direction, and follow vector laws of addition. Done everyone?
Sir.
Great, let's move on. Now, these are the basic things. The main important thing is that vectors follow certain rules that we need to understand. In fact, there is different mathematics for vectors. Okay, just you have arithmetic that talks about numbers. In mathematics, you have got arithmetic. You have got algebra, different rules. You have got geometry, different rules. Similarly, vector mathematics is there, and that talks about vectors and the rules which are related with vectors. Yes or no? Okay. So let's start with vector mathematics. Few people, especially NEET aspirants, they hate this word mathematics. Don't worry, nothing of maths here. Simple rules of vectors. First of all, representation. How we represent a vector. So, suppose A is a vector quantity, okay? So, I will put an arrow over A. That's how I will show that A is a vector quantity, okay? So, if Ram is a vector quantity, I will put an arrow on the head of Ram. Okay, So whatsoever is a vector, we put arrow over its head. Fine. How to pictorially represent it? I mean with the help of diagram. So that's how we represent a vector with the help of a diagram with an arrow. Okay. And this is, let's say, your A vector. Fine. My dear, this is tail of vector. Okay. Right? Tail of vector. This is head of vector. So this arrow portion is the head of vector. This is tail of vector. Head, tail. Clear? Head, what it gives? It gives us,
Direction.
yeah, it gives us direction of vector. What I mean, suppose vector is going towards east. So you will draw it like this. See, head is towards east. Vector is going in the north. So you will draw it like this. Going south, going west. Arrow head will give you direction. Clear? Okay. And what about the length of vector? Please see, this is the length of vector. First note this much. Now, length of vector, what it does? Length provides you with the magnitude of the vector. Okay. A is written in bold letter. Are you using DC Pandey, Bhavika? Are you referring to DC Pandey, physics, DC Pandey?
No, sir.
This, you are referring to this.
No, sir.
Then you are referring to SL Aurora or something. Because in these two books, it is mentioned they have not represented vector with an arrow on its head. They have represented it with bold letter. But dear, how will you represent with bold letter? Will you draw it like this? And my drawing is pathetic. And then you will color it. How will you represent it with bold letter? So that's not pragmatic, you know. They are printing it, they can represent it in blue letter. But what about you? The thing that is internationally accepted, that is an arrow on its head. Okay. Few universities, they also write in bold letters, but that's for the purpose of printing. Because when you are printing, it is easy to print a bold letter than to put an arrow on the head. Okay. So that's all it is, nothing else. You do this.
With this, I'm getting one question.
Yeah, Shireen.
Should we refer any book for physics?
Oh, which book to refer?
Sir,
For
I
what
have no book for
purpose?
physics. Like
For what
you said,
purpose?
DC Pandey for physics questions solving and all.
No, I never said DC Pandey. Hello.
No, sir,
Don't
actually
go
you
with
said,
DC
are
Pandey.
you... No, I have no book, sir. That's why I was asking.
No, dear. DC Pandey is way beyond your scope. If you want to do physics and physics only, then do DC Pandey. It is for IIT advanced, not even mains. Even for mains purpose, DC Pandey is tough. And most of the questions that you do, I give from DC Pandey. So I'm providing you with the practice of DC Pandey, why you need to do it. Theory of DC Pandey, you will not understand. You will hold your head. Theory is too tough. Theory of SC Verma, you will not understand. Too tough. Numericals of SC Verma, JEE mains and advanced, not for NEET, higher level. Resnick Halliday, too advanced for you. It is graduation level thing. Okay. University physics, post graduation. My notes are more than sufficient for you. Okay. Notes. And if you want to practice, so you will get the assignments. Have you got it? Assignments?
Yes, sir.
Please practice assignment, plus you can do these three things. More than sufficient. No, way beyond you. DC Pandey and Sengage. Sengage is BM Sharma. You'll get mad. Don't do it. For NEET, what you can do is, first of all, your NCRT. Solve each and every question of it. Book as well as exemplar. "20 years papers." Chapter wise. Arihant. Okay. And when you are done with these three things, you have to do assignments also, because I will discuss the assignments in class. This much if you will do, you will solve all 50 questions of physics. This much is more than enough. Anything else that you are doing is wastage of your time. Go and give that time to some other subject. Each and every assignment, each and every question. नहीं, एक चैप्टर कंप्लीट होता है तो आप उसमें चैप्टर कंप्लीट हो तो आप मेरे साथ साथ चलिए. फर्स्ट ऑफ ऑल, मूव alongside with me. Okay, simultaneously, once a chapter gets completed, do the assignments. And assignments, if you will see, fragmented them into several portions. Guys, look at the assignment. 5 assignment if you have got. Assignment is related to few chapters that were taught in the lecture 1. Second assignment is for lecture 2, so on. Okay, fifth assignment will be miscellaneous, covering the whole chapter. So keep on doing assignments with the lectures as the lectures are proceeding. Once the chapter gets completed, do the miscellaneous assignment. And after that, do NCRT, exemplar, and the book. And once this is done, you have to do okay. Once a chapter gets completed, this is your responsibility. You have to do this much. And you have to ask me what I will do. I will cover 20 years. I will discuss it. But not now, in March. Okay, I will do 20 years. I will discuss assignments also. But I won't discuss this. This you have to do. If you face any problem, come and ask me. Everyone, is it clear? And the
Yes,
problem with me is that I can't just run away with the course, you know. I have to explain it to you all. Else I feel that I'm cheating. And I don't like cheating. Okay. If students are not able to understand a thing, then what's the use? Then tell them, okay, this is the name of the chapter, go and read. That's like. So length represents the magnitude. I hope it is clear, Shireen. Anything else?
sir.
Okay, do this much. You won't be able to do this much. 70% of this you do. You will clear all 50 exams of 50 questions of physics in your NEET. But try to complete 100%. So what do you mean that length represents a magnitude? Suppose I have got force of 200 Newton. So what should I do? I should draw 200 centimeter arrow. See, that magnitude length is for comparison purpose. For example, I have vector A, it is 5 Newton, and vector B, it is 7 Newton. Okay, so I will draw vector A like this. Suppose they both are in the same direction, and I will make vector B longer than vector A to show that vector B has got greater magnitude in comparison to vector A. That's it. So this length thing is just for the purpose of comparison. Okay. Understood? Please note it. Then we will do types of vectors. Done? Okay. So types of vectors. Guys, are you understanding everything or not? Number one, unit vectors. What is a unit vector? Ram, unit vector.
So vector which has unit magnitude and points in particular direction.
Yeah, right, Bhavika. Unit vector is that vector whose magnitude is unity. Unity means 1. So magnitude is 1. Okay. Vector whose magnitude is 1. That is unit vector. For example, if I have got vector A, right? And no, let's say I have got a vector A and I tell you that vector A is a unit vector. So how will you represent vector A? So write A and put a cap on its head. Put a cap on its head. That means unity vector or unit vector. Anyway, how to make some vector a unit vector? How? Suppose I have got
Dividing that
vector.
vector by its magnitude.
Very good. Suppose I have got vector A and if I divide it by its magnitude, then it will become unit vector. Please see these two parallel lines that you are observing, Shivam. These two parallel lines that you are observing, this is the symbol for modulus. It is known as modulus. In short form, you call it mod. So what is written here? You say A mod is written. What is this? This is A mod. So take modulus of vector A. What do you mean? What do we mean by modulus of vector A? Modulus of vector A means take magnitude of vector A. So how to find modulus of anything? That we will discuss later. Understood? So to make a vector, any vector, suppose there is vector B and you want to make this vector a unit vector. So how to make it a unit vector? Divide vector B by its magnitude. Remember what is magnitude? What is magnitude? Suppose it is written 5 Newton. 5 is the magnitude, numerical value. पहली क्लास में बताया था. 5 is the magnitude. Numerical value is the magnitude. So if you want to make a vector, if you want to convert a vector to a unit vector, what will you do? You will divide it by its magnitude, by its numerical value. Okay. Modulus represents magnitude. That is numerical value. Note it. Dear, I will make you study at least my subject. Understand? Okay, done everyone. Second type. Yeah, Shireen. Second is zero vector or null vector. So what is zero vector or null vector? So vector whose magnitude is zero. Vector whose magnitude is zero. Okay, write it down. It doesn't have any physical relevance. In physics, no relevance. But yeah, essential to satisfy mathematical laws. Okay. Parallel vectors. Curve. Same direction. Okay. Yeah, two vectors are said to be parallel vectors if their direction is same. B and A, their magnitude is not same, but they are parallel. Two vectors are said to be parallel vectors if their direction is same. Okay, understood everyone? Anjana, Bhavika, Gayatri, Shireen. So every time I have to take name of you guys, then only you answer. Huh?
Sir,
No, sir.
Okay. Fourth. Done, 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 done. Equal vectors. So what are equal vectors? Two vectors are said to be equal if they have
same magnitude and same direction.
same magnitude and same direction. So your vector A and vector B are equal. Okay. C and D are equal. Next is opposite vectors. So those vectors which have opposite directions. For example, this is vector A and this is vector B. These are opposite vectors. Okay. Next is negative vectors. So vectors which have same magnitude but opposite direction. Okay. So you will say vector A is minus time vector B. Negative vectors. Clear or not?
Excuse me, sir.
Yes, excuse.
Sir,
Yes.
in opposite vector, the magnitude all will be different.
In opposite vectors, magnitude is
Yeah.
different. Yeah.
Okay, sir.
Okay. Done? Is this much done? Next is, see guys, concurrent vectors, coplanar vectors, all these are stupidity. Co means same, planar means same plane. So vectors in same plane are coplanar. Concurrent is starting from same point. All that is useless. Moving on to orthogonal vectors. Ajit? So what are orthogonal vectors? Perpendicular, very good. So A and B are orthogonal vectors. Understood? Next is unit orthogonal vectors. Yeah, what are unit orthogonal vectors? हाँ जी, कौन कौन से होते हैं? शिरीन, निकिता, दिशा, शिरीन, unit orthogonal vectors. Manal is not here. Okay, Manal is absent. Yeah. My God, you guys don't know unit orthogonal vectors.
No, sir.
I cap, j cap, k cap. These are unit orthogonal vectors. Guys, these are unit vectors. Cap is there and they are at 90 degree. I cap represents x axis. Minus I cap will represent minus x axis. J cap represents positive y. Minus j will represent negative y. K cap represents positive z. Minus k will represent negative z. Clear? Understood?
Yes, sir.
Note it down. Done. Next is multiplication of vectors by scalar. To multiplication of vectors by scalar. Suppose vector A is here and you multiply vector A with a scalar, let's say m. So it will become ma vector. Simply multiply it. That means if 3 Newton of force is there and you need to find 3F, so simply multiply it. 3 into 3, 9 Newton. No need to bother. Okay. If two vectors are getting added up, for example, vector A plus vector B, and you want to multiply scalar, so it will become MA cap plus MB cap. Simply multiply. No problem. Okay. Done. To solve this question, find the angle between A vector and minus 3 by 2 A vector. Find the angle between them. Do it, do it. Use your brains. Shireen, what has happened to you? Today you are not answering. Archana, Bhavika, anyone? See. So Disha and Nikita, good? Yes, it is 180-degree. It was very easy, you know. See, A vector is there. Let us say this is A. This vector minus 3 upon 2, its magnitude is different from A. In negative vector, we have studied that magnitude should be same, but direction should be opposite, right? But here, magnitude is different. So these are not negative vectors, first of all. So don't get confused by minus sign. Minus is there in physics to tell the direction, right? So they are not the negative vectors. But yeah, direction is opposite, like this. So what were these vectors? Opposite vectors or anti-parallel vectors? You can also call them anti-parallel. Anti-parallel vectors have opposite direction. Opposite direction means 180-degree angle. Opposite direction means 180-degree angle. Yes or no? Guys, Shireen, clear or not? Are you there?
Sir.
Are you sleeping?
No, sir.
I think you are. Anyway, note it down. Clear? Can we move ahead? Next is resolution of vectors. See, I am going bit fast in this chapter because this chapter is nothing. It is just rules and regulations, very simple. If I have got vector, let's say A, and this vector A is making some angle with the horizontal theta, okay, so I can resolve this vector into two components. What do I mean by this? I mean I can break this vector into horizontal component, another is vertical. Any vector can be broken down into two components if it is making some angle with the horizontal axis or vertical axis. Okay? Yes or no? So, what's the funda to break it? See, I'm telling you a shortcut. Always remember this. You will never ever make a mistake. It is pas cos dur sine. The thing is, the component closer to the angle will be the cos component. So see here, horizontal axis, how big the vector is always and horizontal axis. Okay, so closer to the angle is your cos component, so it will be a cos theta, and perpendicular to the cos component is your sine component. So it is a sine theta. Clear or not? Everyone, right? So do this. Solve it. You have to break it into two components. Ram, you are next. Hmm? Done. So now Zoya is going to solve. Zoya, na? Wanna erase it? Wait a minute. Yeah. Dear direction there. Yeah, good. And it should be alpha. Angle was alpha, right? Good, 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 good. See, as I was making some angle with the vertical axis, okay, but it is whether an angle with the vertical or with the horizontal. That component closer to the angle will be cos component. Now this much you have to apply the your brain that see force is going down like this. Yes or no? What is the meaning? The meaning is, see, what is the meaning of component? Pay attention. Suppose a player is there, okay, and a batsman, he strikes the ball. So batsman strikes the ball. All of you see cricket? Yeah. So batsman strikes the ball. What happens? So he strikes the ball and ball goes flying. Okay. This is your player. This is the ball. He has given some velocity to the ball. Yes or no? And ball goes like this. Right? The velocity given by him is u. Okay. Fine. Let's say this velocity is making an angle theta with the horizontal. So what is ball doing? Please see. Ball is going in the upward direction as well as it is moving in the horizontal direction. It is doing two things at a time. Yes or no? It is moving up as well as it is moving forward. Hello. That is why ball will reach this position. It will reach till the boundary and it also goes up in the air. Yes or no? अरे देखा है कि नहीं देखा है? धोनी को खेलते देखा है? हाँ, तो बैट चलाता था, क्या होता था? बॉल हवा में जाती थी, तो क्या हो रहा था? बॉल हवा में भी जा रही है और आगे भी जा रही है, ऊपर भी जा रही है, आगे भी जा रही है. यस और नो? ठीक, राइट. So that means velocity given by the player, velocity given by the batsman is doing two things. It is taking the ball up as well as it is taking the ball in the forward direction. Yes or no? So that means there is some velocity, some hissa, some component of this velocity which is taking the ball in the upward direction and some component of this velocity which is taking the ball in the forward direction. Yes or no? So that's what we say, that the component taking it in the horizontal direction is v cos theta or u cos theta, whatever it is given, and here it is v sin theta. Understood or not? Now here force is applied in the downward direction. Ball is thrown like this, like this. So my dear, why were you making it in this direction? You were saying that force is applied towards the right. No, it is applied in this direction. That means it is taking the ball in the downward direction as well as in the forward direction, in the south. Yes or no? So vertically downwards and right, horizontally towards left. Understood? Okay. Everyone, is it clear?
Yes, sir.
Yes, sir.
Suppose this is inclined plane. Who will do now? Ram. Huh? Ram, you will solve, right? And here some weight is kept. Weight. So weight acts in which direction?
Downward direction.
That's how weight is acting, and it is making some angle theta. So who will resolve it? Disha, you come. Resolve it. Resolve you. Yeah. इन इंक्लाइन कैसे लगेगा वेट, कैसे नीचे लगेगा? Yeah, right. Good. Okay. So all these things, resolution, very simple. Note it down if you want. This is a marker. It is kept on a horizontal plane, this book. So this marker is applying its weight in the vertically downward direction. Yes or no? Now if I tilt it, I have tilted the book, please see. Now this book is making some angle with the horizontal. So this marker will also going to get tilted, yes or no? With the book it will get tilted. So how will weight act now? Will weight act vertically downwards? No, weight will also make the same tilt that this book has made. You have tilted it, na? So now weight will act like this. This is my hand. See, here is the marker. If I tilt my hand, marker has also got tilted. So how will weight act now? Weight will act like this. It will not act horizontally or vertically. Okay, weight will not act vertically now. vertically W cos theta will act. Vertically W cos theta will act. Okay.
तो मैंने mg यहाँ लिखा और mg cos थीटा ऐसे बनाया,
गलत है.
तो फिर ये ऐसे बना, तो ये गलत है, पर मैंने कहीं से देख के बनाया.
गलत.
पक्का?
What?
तो ऐसे नहीं बना सकता अब जब
No dear.
हमने एक्सिस को वैसे ले लिया है तो
No dear. That's what I am saying. Please listen. आप अलग अलग प्लेन्स के हिसाब से रिजॉल्व कर सकते हो, अलग अलग एक्सिस के हिसाब से रिजॉल्व कर सकते हो, लेकिन हम लोग जब भी इंक्लाइन का केस होता है,
बाहर नहीं जाओ सर.
सो ये इंक्लाइन है ना, तो बाय ट्रेंड हम लोग इंक्लाइन में ऐसे लेते हैं अपनी हॉरिजॉन्टल एक्सिस, राइट, और ऐसे लेते हैं वर्टिकल एक्सिस. ठीक है, तो इसी के अलोंग हमेशा आपको रिजॉल्व करना होता है. दिस इज कन्वेंशन. ऐसे तो आप जी, आप ऐसे तो लेफ्ट में जाओगे तो भी आप पॉजिटिव ले सकते हो, राइट में नेगेटिव ले सकते हो, लेकिन वो कन्वेंशन है ना. ठीक है, और हर बुक में आपको उसी तरह से मिलेगा. तो रेयरेस्ट ऑफ द रेयर केस है, क्वेश्चन में हो सकता है ऐसा कहा हो कि आप इस प्लेन में रिजॉल्व करो, तो इन्होंने उस वहां से देख लिया हो क्वेश्चन से, क्योंकि जो ट्रेंड है वो यही है. तो अगर आप एब्सर्ड चीजें करोगे नॉर्मल चीजें करने में, तो नॉर्मल करो, एब्सर्ड तो रेयरिटी होती है ना. यस, ओके. सो आई होप दिस इज क्लियर टू यू. Once we will do force, I will tell you inclination and everything. Anyway.
So one question.
Yes, Shireen.
From kinematics, a particle moving along
Shireen, increase your volume.
a particle moving along x-axis has acceleration f at time t. Given that
Particle is silent. A particle along
moving along x-axis has acceleration f.
Right, it is moving along x-axis. Then what?
Its acceleration is given by f is equal to f naught.
Its acceleration is given by
F.
f.
Yeah. And this f is equal to f naught and whole bracket 1 minus small t upon capital T.
Whole bracket 1 minus
No, small t minus upon capital T.
1 minus small t upon capital T. This.
Yeah. Where
This
f
is
naught.
the acceleration.
Yeah.
Okay.
And f naught and t are constant. The
F
particle
naught and capital T are constant.
constant. Yeah. The particle at t is equal to 0 has zero velocity. So at time t 0, we have zero velocity.
Zero velocity.
Yeah. T is
Where,
equal to
where?
0 पे
T
velocity
equals
is
to
0.
0 पे small t equals to 0. So particle's velocity is 0 at this point, right?
Yeah.
Okay.
At the instant when small t is equal to capital T, the particle's velocity is equal to.
Find particle's velocity at the instant small t equals to capital T.
Yeah.
Acceleration is given. Need to find velocity. So what is done? Acceleration. Then velocity has to be found out. Equal to integration of a dt. Integrate this thing. Okay. When you will integrate with respect to time, so 1 minus t upon cap, what all is there? So all these are constants, they will move out of integration. F naught minus F naught upon 1 by t. That's what is there. Right? Integration of this. Can you integrate it or not? This will become F naught t, this will move out. Integration will be t square upon 2. Now in place of t, you have to put capital T. What was the problem here, Shreen? You were not getting answer. Shreen?
Actually,
Shreen.
it was given in terms of f, so I was literally very
It
confused.
was given in, again I can't hear you.
Now
given
I'm
what?
getting the answer. When you told, I got the answer.
You got the answer.
Yeah, now I can solve by this. We have to equate the value.
Okay, Shreen, we will discuss this question tomorrow. Okay?
Okay, sir.
Bye-bye.
Yes.
Take care.
Thank
And
you,
please
sir.
integrate it. It is very simple question, dear.